Okay, I think we can go ahead and get started. Hi everyone. My name is Jose Hotema, and I just want to welcome everyone, whether you're joining us live here or watching this from the future from a recording. I'm super excited to be here with my guest today. Today we're going to be discussing fashion meets fulfillment, automating apparel induction the smart way. And I am joined by Chris Caldwell from Yaskawa and Nick Herbon from Eurosort. So, just to kind of get everybody nice and comfy, I'm going to tell you a little bit about myself and our guests here. Starting with me, I am the solutions engineer at Plus One Robotics. I originally started in hardware testing, seeing what makes the robot break, work at its best, or whether that is, you know, package types or stressing the vision, things like that. And one of my first guests here, Nick Herbon from Eurosort. Nick, can you tell us a little bit about yourself and your background to everyone in the audience here?
Sure. Hey, great to be here with you guys today. Thanks for having me. So I'm with Eurosort, obviously been with Eurosort for 12 years, been in the automation space since 2005, so going on 21 years-ish.
Hmm.
Previously with manufacturing automation, things like solar panels and medical devices, and then last 12 years, like I said, with Eurosort in the distribution automation space. Live in Riverside, California, father of two daughters and husband. And yeah, love doing this stuff and look forward to sharing a few insights with you today.
Awesome. Thank you, Nick. Chris, now on to you. Chris is from Yaskawa. Other than that, can you tell us a little bit about what you do and what company you're coming from?
Yeah, absolutely. I'm Chris Caldwell, Senior Product Manager for Material Handling Applications. Been in product management in a handful of industries for a little over 25 years. So I've been around, worked in a couple other places. Most recently, prior to Yaskawa, I worked in a manufacturing company as a supply chain and operations manager, including having the responsibility of our shipping and receiving warehouse reporting up through me. So have had through different types of manufacturing stints in product management, as well as managing a couple different warehouses. I've had some background in history in the fulfillment and working in an e-commerce company, as well as a variety of different types of disciplines reporting up to me. I also, Nick mentioned, so I have four kids, currently dealing with college applicants and
Nice.
college first semesters with different ages there, the ages ranging from getting ready to turn 19 to getting ready to turn 11.
Oh man, yeah, I'm sure the robotics are hard, but I'm sure being a parent is much harder.
Yeah, the
All
robots
right.
don't talk back as much, so we can work with those a little bit easier.
Right. Let's
Indeed.
keep exactly. Let's keep it that way. Okay. Thank you guys for introducing yourself. For the audience, just to kind of give you a quick little summary of what it is that we're going to be talking about today. Our discussion is going to focus around, the difficulty and or how easy or difficult it is to actually program and implement industrial robotics into the apparel world today. Two, the biggest bottlenecks in apparel fulfillment and how automation is addressing them directly. And when automation starts to make sense, right? Whether you're looking at it on a, increasing scale of operations or simply looking to get a larger return on investment, right? Or maybe it's about the personnel that you're hiring. A couple notes to take and before we get started here. If you have a question, please put it in the chat. Feel free to chat, put it in there, and we'll address it at the end. And then also in today's presentation will be recorded. So if you're attending or you show that you were attending, you will receive an email with a link to the recording. So if there's something that you missed or feel like you want to take note of again in the future, you know, definitely come back to this and watch it at 0.25 speed or 2x speed, if we're talking a little bit too slowly for your taste. Awesome. So let's move on to the main content of our webinar. And actually, I'm going to start with Chris Caldwell from Yaskawa. So I'm going to go ahead and, lay it to you straight. address the elephant in the room. Apparel historically is one of the more difficult applications to implement robotics into. What is it that makes apparel so hard to automate and implement with robots?
So some of that is, as you mentioned, historical. Throughout all time, fabric is one of those things that's fairly difficult to grasp, and a lot of the different apparel manufacturing and apparel fulfillment had previously been to go direct from manufacturer, and everything was headed towards a brick and mortar fulfillment. And so
Right.
things didn't have much packaging around them. And so vacuum is one of the primary forms of gripping, primary mechanisms used in trying to pick up fabric that is very permeable for air had previously been difficult. As we look into how it is to implement automation today, some of the just changes in industry have opened up automation and made it easier looking forward, because the fulfillment has changed from direct from manufacturer to brick and mortar into more distribution and e-commerce where things are packaged during the manufacturing process.
Right. I see what you're saying. I would assume that the industry didn't necessarily change from, just shipping out, loose fabric to now anytime you receive like, clothing in the mail, it's usually comes in these like either clear bags or white poly bags, which actually makes it easier for robots to grasp. Was that intentional with robots in mind, or was that like, or were robots just a secondary beneficiary?
I think a lot of it was not intended specific for automation, but a lot of the developments for the broader e-commerce and fulfillment industries have benefited, and then that made it easier to robotize.
Right.
And then along with that, the clear poly bags and white bags with solutions such as Plus One, the segmentation there works very well. But traditionally, prior to some of the development of the new AI-based vision systems that allow that vision-guided robotics to get in there and move quickly and reliably, there weren't pre-taught points in the past. So it was kind of a combination of multiple developments in the last
Right.
10 to 15 years, really hitting their stride in the last 5 years that have opened up automation for the apparel fulfillment industry.
Nice. I like that. Awesome. Let's get on to our next question. So, Chris, whenever a customer asks, can a robot handle apparel? I know you kind of got into that a little bit, but what is one of the first things that you evaluate?
So the first thing to look at is, again, how can we segment that? Can we see as it's coming down? And then how precise do they need to be? One of the benefits on handling apparel, especially through the fulfillment industry, is there isn't a lot of highly precise pick and place. And so we can run a robot, detect that item, segment the item very quickly, and we're able to run that robot at a very high speed and go to center mass, pick that item and move it. So being able to handle those, some of the key points that we look at is airflow, cell design, and the speeds that they're looking for to make sure that we can grasp those individual packages very
Right.
consistently.
Right. And then for the audience that kind of might not be super familiar with this application, the name of the game is singulation. Most of the time when, these facilities, whether it's fulfillment or even for returns, a lot of them come in batches. And, normally it would, traditionally you manually have to separate these and scan these one by one. So with the robot separating these, you can just send them through a scan tunnel and that makes it a lot easier, right? Or you can place onto what, like we're about to talk a little bit about, is onto a sorter, which actually brings me to you, Nick, on the sorter side. Assuming, the robots are inducting to a sorter, what does a good induction look like? Or what is the quality required for a sorter to perform at its best?
Sure. Yeah, I mean, you've got a sorter generally moving at, something like, 200 feet per minute, 220 feet per minute, somewhere in that range. And the sorters are made up of trays, right? So if a robot's going to be doing the task well, its job is to make sure the item gets into the tray. I mean, that's almost stating the obvious, but That is the name of the game. Now, apparel, as you started with, can be a little more difficult to handle, maybe a little amorphous. So Eurosort, this video is kind of a good example. Have worked to develop some accessories, if you will, that can make automated induction, robotic or otherwise, a little more successful, right? So this is showing our tipper. This is actually in the demo center that we've worked with Plus One on. And so this is a device that's decoupling the robot from the sorter. So rather than the robot standing there waiting for an induction point to place an item, the robot can place the item onto the tipper, go away, grab the next item, and then while it's away, it can be the tipper can induct the item onto the tray. So that decoupling is part of what good induction looks like. We have other accessories. It's all born out of customers' needs, right? A customer may have some uniqueness to them, something we haven't seen before, and we like to, develop new accessories and tools to meet their needs. Maybe it's something as simple as a funnel on the tray, that allows us to be a little sloppier. That can be the way to go. Maybe it's some type of controls mechanism. So if induction is slightly, call it sloppy, we can mitigate that by perhaps rejecting that item before it becomes a problem. A problem being maybe it stops the sorter, or it's a missort. These are things we obviously design out of our systems. With enough experience with partners like you guys, we're able to do all those things.
Right. I mean, historically, the robots haven't, maybe recently, a little bit more recently, the vision and the systems have gone better, but historically, robots were kind of, would just kind of fling things, and you still have to be able to, to catch it. So if anything, it's probably gotten easier in the last few years than it was in the beginning, I'm sure, right?
Yeah, I mean, for sure, they've gotten better. Yeah, the partnerships between the accessories we make and the robot. I know we're gonna probably get to it, but if you can get a robot to do what a robot's good at, you're gonna be more successful. If you give it a very difficult task, it's not a
I see what
lot of
you're
way to
saying.
be successful.
Yeah, that actually brings me to my next question, Chris. A big pushback that I used to, have whenever I was on the consumer side of things is when I was thinking about robotics and how things are integrated. From my experience, robots are, these complex machines, time consuming to program, and somewhat even expensive to get a programmer for. So, in your opinion, what does the typical deployment of a robot looks like into, apparel facilities?
Yeah, that's something that I think industry-wide has been a focus. I know certainly here at Yaskawa, we've put a lot of time and effort into coming up with some easier to use tools, both for programming as well as access into our robot controller. So as we've moved on and gotten away from a lot of the applications that were all pre-programmed, robot is very repeatable, hit these points time and time again, and gotten into vision-guided robotics, and then develop tool sets that we can provide to technology partners, vision-based companies, that they have access to the APIs in our robot controller, and there's not nearly as much core robot programming anymore, because we're not telling that robot to go to the specific point over and over again and trying to tweak and design out that efficiency. We're detecting those objects and then going to the an approximate place location, and as he mentioned, having those segmented trays and getting those sorters into facilities has given us a little bit more of an easy to synchronize target that we can, through different types of end-of-arm tooling, sometimes we can drive the robot to a blow-off and kind of throw it directly into a tray without really stopping and slowing down the robot at all. So a lot of our focus has been to give tool sets to make the robot less cumbersome to program, and then also we operate a full academy here to train people to the level that they need to, from basic all the way up to very advanced courses.
Right. No, that makes sense. So, like, if you're an experienced programmer, is it going to take you anywhere from a day to a week to actually going from, installation to go live? I know with the vision, it's pretty plug and play, like you said. So you're no longer hard coding positions, but would you say a day, two, or a week?
Uh, some of it really varies on cell. If you have kind of a repeatable cell, a lot of times you can have that entire thing up and running in a day. There's just a little bit of
Right.
registration to go through. Depending on how tight the performance tolerance is there, you can frequently get up and running and after you have, mounted, wired, and connected the actual programming, you can get up and running in a day, but then where you can run into some time is really optimizing performance and tweaking things and trying to drive things around. But generally speaking, we are less than a week for most deployments to get things synchronized and really dialed in pretty well.
Yeah, I think that's definitely in agreement to what I've seen in deployments, and I would argue that much of this is because robotics in fulfillment is actually more of the newcomer. Robotics
Mhm.
have been around in manufacturing for a while, so I'm sure a lot of this is just industry standard at this point, right?
Yep.
Okay, so in that case, so we kind of talked a little bit about what the robot timeline looks like. What about for Eurosort? How long does it take to install a sortation solution? Specifically, like at a brownfield facility where, when it was first built, they didn't have automation in mind.
Sure. Yeah, no, great question. I mean, lead time wise, a typical loop sorter, and we're talking a sorter that's, maybe a couple 100 feet long, 50, 60 feet wide, something like that, rather large piece of automation. You're on the realm of, 6 to 8 months from purchase order to go live. Front end of that's obviously, engineering, tail end of that's implementation, right?
Right.
Specifically to brownfields, it can be done in a number of different ways. It depends on the situation, obviously. Did the customer have some space in reserve? Obviously, that's a good easier path. Or if they're out of space already, I mean, we were just doing a job there in Texas. We ended up putting the sorter up on a second level on a mezzanine above the existing automation. So, that adds a little bit more complexity to it, but pretty common these days. Buildings are not stretching, right? They stay the same
Right.
size. So doing the brownfield thing is very, very common these days. And making sure the building's up and running while we're doing it is obviously a must. Folks aren't going to be able to be down
Right. I
for
was just
extended
about to
period.
ask that. Yeah, it's like
Yeah,
how does the entire facility have to be
no,
stopped? Do you guys usually do it in sections?
no, no. I mean, so we're going to need a lay down space. You know, it's going to be, if it's the two of us working on a project, there's usually a third entity, an integrator, and we're going to partner together and get the proper amount of space fenced off or just coned off, whatever the requirements are in the building. Um, if it's on a mezzanine, obviously that has to come first. The obvious things. Um,
Right, right, right. No, that makes sense.
when it
Okay,
comes to
so
the robot, I want to dovetail off of something Chris was saying a minute ago, right? You've got the sorter in place, you've got the induction area in place, at least the platform. So now the robot can get in place, the cell can be put in place. But he mentioned that day or week of configuring and programming the robot. I think it's important for the folks in the room to understand that day or week took place in the lab, right?
right,
That
right,
didn't take place in your building. If we, we're thoughtful about the process. We have a demo center, you guys have a demo center. Um, so, whether it's in San Antonio or Maryland in Baltimore, doing that setup, having the client send us some product samples
mm,
and doing the machine learning there, the AI learning can cut down on the time in on site so that we develop that recipe, primarily you guys develop the recipe and then boom, 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 boom. It's just, cookie cutter from there with caveats, I'm sure. But that's
no,
ideally the way to kind of make that week or day be less noticeable to the end user.
yeah, I would agree with that. Actually, you just hit on a great point. A lot of the work or the tuning work is done, weeks or even months before the day that you're even installing the first bolt, whether you're turning the first wrench, you kind of already know what worst case, best case scenario is going to look like. So great point right there. actually. Which actually I'm gonna brings me up another question. Whenever, and this is I guess related to integration. We can start with Chris, we can start with Nick, but where do you guys think typically get stuck during the integration? Or at what point in the project timeline do you feel like you have the most amount of like back and forth with customers?
I mean, I'll start, Chris. I think for my experience, whether it's just automation in general or automating and there being a robot involved in the induction area, um, where I see pitfalls for clients is when there maybe wasn't complete adoption internally, right?
Mm,
Did they get everybody on board? Maybe there was a specific key stakeholder, especially in larger organizations, they were out of the loop, they were misinformed, or maybe just not on board. Um,
right,
you
like
know,
the operations team versus,
that's a
the
good example. I mean, that would be a disastrous example, right? If the ops team is not on board with this, um, your ramp plan will go to H. So yeah, you got to have everyone on board. You got to have these conversations early. It obviously starts at the top, but if the top forgets the bottom, I promise you it won't go as smoothly as it can.
right.
Um, the other one would be just simply like I see folks that are best at this as guys or guys and gals that are disciplined at looking for things that they're automating things that should be automated. I think
Mm,
I think one of us mentioned that earlier. Like you don't look for automating a process that a human can barely do. Um,
right.
you got to look for something that the automation will be well suited for. So if you
Right.
do
I
those
always say
things,
I
you're
always
gonna
say
win.
the dull, dirty, and dangerous, specifically dull because, it tends to be repetitive.
I think that's one of those key points to definitely.
Oh, we lost your sound right there, Chris. Let me see. I think you just
Is that
muted.
back?
Yep, got you back.
All right. So one of the key things there, this come in with bringing in experts like Nick at Eurosort, bringing in a system integrator, plus one on the vision side, us on the robot side. Frequently, to really set yourself up for success and make sure that you don't get bogged down, you start with the low hanging fruit, places that have been successfully automated either directly in your industry or a lot of times as we're looking at apparel, a lot of the developments that came through for the broader logistics and e-commerce industry have translated so well to apparel because they changed their kind of fulfillment and go to market. And then, as you mentioned, the return cycle once they made that change, people weren't returning all of their goods to that brick and mortar. So they had to open up this channel to be able to get those goods back in their systems. There are solutions that exist out in the industry that can be leveraged very well. Not to say that no science project should be undertaken, but like Nick talked about, where you're working in a brownfield, they don't want to work on a science project in that brownfield and potentially bring up problems for their day-to-day operations.
Right.
Some of that can be done offline, but really, as you're trying to retrofit into these brownfield facilities, what you want to do is have those people that are experts come walk that facility, find the easiest place for automation. As Nick said, you don't want to try and have, especially if it's your first stab in automation, don't try to solve the project that a human can't do, because if you don't know how to get it done with human capital, I can just about promise that you're going to have difficulty automating it. And so looking at solutions that exist, finding proven applications, sometimes you can tweak them as needed, but really just looking for this is where I know I can get my ROI. These are the places that have proven documented success and hitting
Right.
the throttle there.
Right. That actually kind of segues well into my next question, which, I want to know what the most successful apparel companies are already doing to keep up with demand. Think, the Gap, Arrow, American Eagle, all these kind of name brands, solidified players in the industry that have, tens of thousands of customers. How are the biggest brands meeting fulfillment today?
some of the benefits and the ways that they're able to do that, they get those absolute strength of economies of scale. So they're able to roll out automation. They have lines that they're able to easily integrate robots into a line that was made for high volume. They can still have a pretty wide product mix, but generally speaking, the processes that are happening at scale large enough that you can still have hundreds or maybe thousands of different SKUs that follow a fairly similar size and shape, and you're
Right.
able to run those on common pieces of equipment. And then they have sometimes different facilities, but at least different lines for things that are very far outside what a standard definition of a product that would be. So you're not going to be running, 5XL puffer jackets on the same piece of equipment that you're going to be running a single tank top. I know on the robot side, not specific to apparel, but I had a real fun conversation with a company that said, I want to have one solution that can pick up a pen, but it can also handle a couch. And I said, well, that's just unrealistic.
Right. Right.
I can get you a total cell that can handle everything in between, but now you're far over engineered and you won't get the cycle time that you're looking for. So the most successful companies, the largest companies, they can build their automation at scale to handle the bulk of their business, and then they can understand very well the places, whether it be having parallel lines that can handle only their peak, or where they can integrate flexible human capital to be able to come alongside those automated systems, or where they can justify the ROI of building out something that only runs day to day at 80 or 85%, where you can flex it for those peaks.
Right. That makes sense. And I guess on the sorter side, like what are the most common failure points whenever you've, worked with the Apparel Induction? Is it, misscans, jams, or whether it's before or after you come in? I'm sure a lot of customers come in with existing problems. What are those problems that you see a lot of times?
Some of it, Chris touched on it, is starting with maybe unrealistic expectations, right? There's going to be some non-sortables, some I use the term robot compliant, right? It's like items that just don't deserve to be sent to the robot. Larger companies are able to leverage their supply chain. It could be as simple as put a dang poly bag around it. That's going to help a lot. It could be as simple as make sure every item has an LPN or a label on the outside of the poly bag. That's going to make automation easier. Those things aren't as easy for smaller companies. From what I hear, I haven't been in one, but yeah, those are things that they can certainly leverage their size for. But what I see them also really excelling at is exactly what we're here today to talk about: marrying technologies, right? Bringing in the best of the best. A high-speed sorter company that can do, upwards of 500,000 units a day on a machine, with a robotics company, but marrying maybe some manual induction with robotic induction to get that right blend of handling as close to the 100% of the products as you can.
Right.
Is something they can flex their muscles and do. Ultimately, it's a labor play. They want to reduce labor and increase throughput, maybe in the same amount of space. So I don't want to say it's not possible for smaller companies, but the larger companies just have more throughput, so their ROI is just naturally going to be kind of on a faster track.
I see what you're saying. Right. And I guess that brings us kind of to one of our last questions for this session. Once the robots have gone in, the sorters have gone in, the systems have gone live, let's say for, the first 3 months, what are some performance metrics that matter most when evaluating your new apparel induction solution?
I think on the robot side specifically, we are most commonly judged that robots have established success where they have uptime that is incredibly high. They have uptime
Right.
and longevity, but specific on induction and different types of fulfillment operation, it really all comes down to the throughput, the number of units per hour that they can handle, and then how error recovery is handled. Some of that goes into cell design, some of that comes into implementation, some of it comes into scoping what those edge cases are and where you can divert things out to keep the 90+% of your products that can run without an issue. But those really are the primary KPIs, the things that we keep track of for the robot side of things, because it all comes down to when you're meeting the ROI on the robot is I need to move this many pieces per hour, and this is my budget to get that done.
Right. No, that makes sense. Throughput and uptime. I like that. Nick, what about for you? What do you think are some KPIs that can really help?
Yeah, those are two of the bigger ones. Uptime is important because a robot and a sorter, they both have a direct relationship on uptime when you're talking about robotic induction. If the robot or the tipper miss the target, you could, reduce uptime. So we're gonna be watching that one like a hawk. Read rate is another important one. So you have in the apparel world, you kind of have two categories. Third, if you count omni-channel, right? You've got retail, replenishment, and you've got e-commerce. You can do omni-channel, of course, and be somewhere in the middle. But with retail, a lot of the times you're inducting out of a pure SKU case, right? So a carton comes to the induction area. Maybe for a robot, it gets dumped. Maybe it doesn't. But it's one SKU that the robot is grabbing over and over again and kind of distroing it to the stores. So the scan is done. The job is done. That robot can fly, right? Just boom, 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 induct, induct, induct. Only scanning the case the once and first time. Eurosort's going to keep track of which tray the items get put onto. Right. And we don't need to scan each time, right? We don't even need a barcode on each item. So with that example, the read rate should be 100%, right? As long as they scan the carton and the carton has a valid barcode. Mm-hmm. Then you get to e-commerce and you're picking items into a tote, or maybe an ASRS is bringing items to a pick station. And anyways, rainbow totes, if you will, totes full of random items are coming to the induction area. And now you need to scan each item. So, thankfully, folks like yourself have that type of approach nailed, and you get the scan. But, if it's a more difficult to read barcode or item because it's some shape, read rate's something we definitely keep an eye on with you and make sure that, we can get a good scan, because if we don't, we can't obviously sort it.
Right. Like we said, these packages tend to be a little bit, cloth and apparel tend to be a little bit more, flimsy. So those barcodes get a little bit hard to read. So I can see that being a good metric to judge the system by. Awesome. I like this. Okay. So we did get a question in the chat. I believe this one is for Chris. So Timothy says, you mentioned that robots are getting better all the time, and that if you ask it to do a basic task, it will perform better than a complicated one. How do you know when to pull the trigger on a specific robot type and not wait for the next gen model?
I think the robot guy in me also got a great little bit of information just this past week, and spent time down at the A3 forum learning about kind of the developments in the industry and where things are going. One of the things they talked about there is just generally speaking, companies have put a lot of their automation projects on hold due to uncertainty. And I think a lot of that was talking about interest rate uncertainty, economic uncertainty, but some of this can also be the uncertainty of, is now the right time to deploy a system when maybe I can wait another year? And with a lot of companies having waited a year or two at the moment to deploy some automation, the key point that was talked about there is the risk of not deploying automation is currently outweighing the uncertainty risk that exists in the marketplace. So if you are looking at a solution that has any amount of proven success in the industry, the risk of waiting out and trying to say, well, if I wait another year or two, there might be a robot that has, a 2 to 5% reduction in its cycle time. A lot of times a properly designed system is going to make a lot of that reduction irrelevant.
Yep.
Across the industry, robot models, the castings change about every 5 to 10 years, where you get a true leap in performance that you're measurable. There may be a new single model that hits a payload and reach combination that outperforms something before, but outside of that, you're looking at very small iterative improvements, and a lot more of that improvement comes down to cell design, program flexibility, the vision system.
Yeah.
On the robot side of things, I would seldom say that it's appropriate to wait until the next gen model. It's more important to make sure that you're looking at a proven and trusted system that you can actually do a correct calculation on the ROI, and that you have a good integrator. You trust the experts in the room. So you have a good sorter, you have a good vision system, you have a good robot company, and then you really nail that integrator selection.
Yep, I think that's a great way to put it. Just to kind of add on to that, most of the robotic systems, the cool thing, like we were talking about earlier, the robot part has been vetted, whether it's the manufacturing industry or other fulfillment industries. The way that your robot, quote unquote, improves even after the day that you buy it is through the AI or the vision system that you implement into the robot. The robot just follows the commands of the AI or the software. So, definitely don't wait to, pull the trigger on a robot. Just make sure that, like you said, the integrators and the software going into it are, ones that are constantly innovating. So we have another question here, this one can be for both of you guys. You talked around how properly scoping a project is important for success. Where else can implementations run into trouble?
I can try to go first on that. But I think one of the things that comes up is, regardless of how well scoped anybody thinks a project is, especially when it comes to fulfillment or the return cycle, things creep in that weren't planned for. So a return system may end up having an item sent back in that was never produced in that facility. What are your error recovery options, and how flexible and how do you implement that interaction where the cell was never designed for this? How do I get that kicked out into a reject station where a human can do it? How can I, some of that goes into scoping, but it really comes into, how do I handle that unknown? How do I plan for things that never should have been put into this system? How do I give it an easy out? How do I implement a system such as Yonder to get a call out that can be resolved in the minimal amount of time and keep that capital equipment producing? That is a big part of keeping that implementation from getting bogged down, because what frequently happens is you go through, you think you have the best designed cell, you go to do the runoff, somebody throws a wrench in it. I'm really great at it when we're making our demos here in house. I'll walk by and toss something that it was never meant to handle into a cell and just watch what it does. The reason for that is that's real life, and that's what humans are really good at, that sometimes automation systems, robot or otherwise, sometimes struggle with. And so really getting robust, and sometimes it is just dedicating space to say, this is where I'm going to shove my rejects, or this is how we're going to collect the things that inevitably fall out of a tray or get thrown by a robot. What happens when you lose power? How do you get your recovery? How do you maximize what you're getting out of this and allocate for things that don't go to plan?
Yes, having a clear alternative for exceptions. I think that's a great answer. All right, guys, we're going to move on to our final section, just so everyone is a little bit more familiar with your stance on things. I'm going to ask you guys a set of 6 rapid fire questions. We're going to start with Chris, and I want you to be quick. Don't really think about it. Just first thing that comes to mind. I want to get to know the real you. Okay, so let's start with Chris. Yes, you ready?
All
right, let's go. One word to describe the current state of apparel automation.
Growing.
What's an everyday task you wish robots would do for you?
Dishes.
What's the most optimistic thing customers say right before a project gets complicated?
I've thought of everything.
What color does a robot look best in?
Obviously blue.
Favorite drink to start your day?
I'll start with any energy drink I can get for less than $1 a can.
Nice. And robots are humans. Where do humans still clearly win today?
Emotional support.
Nice. Good. I like this. Awesome. Okay, let's go over to Nick. You ready for your rapid fire?
I guess.
Nick, what is the weirdest thing you've seen go through a sorter?
Boat anchor.
Voting. Early mornings or late nights? What makes me more productive?
Early mornings.
Early mornings. Brownfield or greenfield? Which one scares you more?
Yeah, brownfield.
Brownfield. Manual induction, underrated or outdated?
What were the two choices? Sorry.
Manual induction, underrated or outdated?
Tough choice. Third choice being still has a purpose in the world. I mean,
Nice.
still needed.
What's the phrase customers say that makes sorter engineers nervous?
Perfect.
Perfect. What hobby helps you completely disconnect from work?
Off-roading.
Oh, dang. I didn't expect that one. Awesome. Thank you, guys. That was it for the rapid fire questions. We're going to move on to our closing remarks. So, just so that everybody is aware, Plus One will be on the road soon, and we are hoping to meet up. Screenshot this to, see where we're going to be at next and where we could potentially meet you. And as always, feel free to email us and contact me via LinkedIn or email. And if you can go ahead and sign up for our next webinar, we are going to be sending out details soon. This just puts you on our email list so that you can stay updated. And we are super happy that Chris and Nick here joined us. Chris, do you have anything to tell our audience before we close out?
I'd say generally just if you have a process going on in your facility, go ahead and look into a robot.
Right. And Nick, anything you want to tell the audience before we close out?
No, I appreciate you guys hanging in with us today. This is something we value, working with partners like Plus One and Yaskawa. If you're going to be in Atlanta for Modex, be sure to stop by and say hello to myself and the team. We'll be at booth B9904, but you'll find us. We're right on the aisle. Great chance to see what's new in the industry and to see some old friends. So come say hi.
I appreciate it.
That was
Awesome.
a much better plug. We'll also be at Modex. I didn't have my booth number ready because Nick was far more prepared.
Well, it's probably too early to even give a booth number, so you're fine.
But yes, be on the lookout for Modex and any future. Stay connected with us on LinkedIn. Follow Nick and Chris on LinkedIn as well. They're always open to conversation. So if you have any questions following today's webinar or want to discuss more about Plus One Robotics, please reach out to me or Lisa and we can connect you to either of our speakers. And thank you to our guests and everyone that attended. I'll see you everybody in the next episode. Thank you guys.
Bye, everyone.
Thank you.